Welcome to Empirical and Molecular Formulas. I'm Mr. Markarian. The empirical formula, as you guys remember from the notes, is the lowest whole number ratio for a chemical formula, for a chemical compound. So if we have something like, say, C2H6, which is ethane, if we take that thing and reduce it down to its lowest whole number ratio, the best way to do that is to divide by 2 in this case, and we'll end up with C1H3. So that is an empirical formula of, it is the empirical formula of C2H6. So having that in mind, that's a key concept to get down. Again, it's like a recipe. If you're trying to make pancakes or something like that, there's the recipe amount that you get from a cookbook, but if you need to double or triple it, depending on how many people you're having over, or have it, if you're lonely and eating by yourself, then this is a lot like that. So the ratios are all the same, but the lowest for the example of C2H6 would be CH3. Okay, so here's a practice problem for empirical formula. The question says a substance contains 48.38% carbon, 8.12% hydrogen, and 43.5% oxygen. And it asks, what is the empirical formula? So as we're going to solve this one, the first step is to always take the percent and just turn it into grams. They all add up to 100%, so you can just say you have a 100 gram sample. So percents become grams, and then eventually you got to convert grams to moles. And the last step is to get it into, oops, kind of having a hard time here, get it into whole numbers. Okay, so that's the first series of steps you want to go through on here. Okay, so looking at the carbon, we have 48.38%, which I'm going to automatically make grams of carbon. And if we take and convert that into moles, which is the second step, those are 12 grams per mole. And when I do this in a calculator, I get a number that's pretty close to 4 moles. So we have 4 moles of carbon. I can do this for the hydrogen as well. That's 8.12 grams of H. 1 mole of H is about 1 gram. And I get about 8.12 moles of hydrogen. And then we're going to do the same thing for the oxygen, same exact setup for that. And once you get that one done, you're starting out with 43.5 grams of O. Forgot my units. And 1 mole of oxygen is 16 grams. And that's going to equal 2.72 moles. Okay, so if we write this out, we have carbon, hydrogen, and oxygen, and we've got a 4 there. The hydrogen's about 8.12, and the oxygen's 2.72 moles. Well, these aren't whole numbers, so we're going to have to figure out what to do there. So I'm going to take and divide by the lowest, which is 2.72. And I'll take and do the math on these. So that's going to be 1. That one's pretty easy. The carbon comes out to like 1.47, which is pretty close to 1.5. So I'll just go ahead and say 1.5. And then the 8.12 divided by 2.72 gives us 2.98, which is honestly close enough to 3. So I've got a 1.5, a 3, and a 1 in that case. So if we rewrote it, we would have C 1.5 H3O. But we don't have whole numbers. So the best way to get whole numbers when you have a 1.5 like this is to take the whole thing, multiply it by 2. That 2 distributes out to everybody, and so you'll end up with the 2 going to the 1.5, the 2 going to the 3, and the 2 going to the 1 that we don't usually write there. So we end up with C3H6O2. That is the empirical formula, which I'll just put EF for that. That is the lowest whole number ratio for this substance. Okay, so a follow-up question to the last example could be something like, what is the molecular formula of the last example if the molar mass of the molecular formula equals 148 grams? So in this case, we will take our empirical formula, which was C3H6O2, and we need to figure out how much that weighs. So this formula has an empirical formula mass, which we're going to call EFM, or write EFM for short. And the empirical formula mass for this guy, if you go to the periodic table and add up 3 carbons, 6 hydrogens, and 2 oxygens, appears to be about 74.0 grams. That's the empirical formula mass. Well, the mass of the actual molecular formula is 148 grams. So to figure this out, real simple, I take the 148 grams for the molecular formula mass, and I divide it by the 74 grams for the empirical formula. So that's molecular formula divided by the empirical formula mass, and that gives me a factor of 2. Well, I then take that factor and I multiply the empirical formula by that factor. And so we end up with C6H12O4, and that would be the molecular formula of the substance that we're concerned with. So that would be the answer to a follow-up question like that. Usually on a test, though, I just ask it as one big question. I would say something like, what is the molecular formula of a substance that contains 48.38% carbon, 8.12% hydrogen, and 43.5% oxygen if its molar mass is 148 grams. So you can hear that I'm taking the question and putting it into one big question. Let me show you what that looks like. So here we have the question as it would be written on a test, and you notice we've taken everything, combined it together. It says, what is the molecular formula for a compound that contains that percent of carbon, that percent of hydrogen, and that percent of oxygen if the molar mass is 148 grams? So just to, again, outline the steps for this thing, you would go percent to grams, grams to moles, get the whole numbers, and that gets you the empirical formula. Once you know the empirical formula, you want to get the empirical formula mass from the periodic table, and then from there you'll take the molecular formula or molar mass, divide it by the empirical formula mass, and then use that factor, whatever it is, and multiply it times the empirical formula. And that would give you the molecular formula. So it's that series of steps. I mean, it's every time, same thing, percent, grams, moles, whole numbers, get your empirical formula mass, divide that into the molecular formula mass, use that factor to figure out the molecular formula. It's a lot of steps. It's complicated at first, but with enough practice, it's usually, not too bad. So definitely, if you need more practice, Google empirical formula and molecular formula practice problems or something like that. There are a lot of good resources. Chem Fiesta is really good for practice problems in addition to what I've already given you. And just go through the steps. You can also take a formula of a known substance and you can figure out the percentages yourself from that, and then go back and do empirical formula. So, it's nothing too difficult. You're going to get one question like this on the test. I hope this was helpful. If you have questions, message me on Schoology, and I'll get back to you as soon as possible.